Are we going to have the tests on the same day? Ariana, since you guys have Tuesday lab, you don't. You'll have your Tuesday lab exam on Tuesday, normal time, and your lecture exam will be on Thursday. The Thursday lab people will have both tests on the same day though. Okay, integumentary system has to do with your hair, skin, and nails. And we're gonna focus specifically on the layers of the skin here and the structures within these layers that are important to know. So the epidermis is the outermost skin layer, the epidermis. The dermis is this middle layer of skin, and then the hypodermis is just adipose or fat tissue. The hypodermis isn't actually a part of your integument system, but we include it in this picture labeling. So there will be a picture like this or similar to it on your lab exam. Within these layers, you see hair shafts, which are a part of the hair that extends above the surface, the epidermis. And then the hair root is basically the hair bulb, which is where the hair starts to grow. The hair follicle surrounds the hair root. The sebaceous glands secrete oil around the hair itself. Here's a duct of a sweat gland that reaches up to the surface. And here's a sweat gland. The Erector Pili muscle is the muscle that allows your hairs to stand on end in goosebumps. Here's the papillary layer of the dermis. These papilla are little bumps, and that's why it's called the papillary layer. Within these bumps in the papillary layer, you have different blood vessels going through to help give blood supply to the layer of the epidermis that's above it. And then the reticular layer is everything below it. What else? We have Pacinian and Meissner's corpuscles, and these are tactile receptors. They just help you to detect pressure and touch in the skin. I think Pacinian corpuscles help to detect deep pressure sensations if you were to touch something. And a Meissner corpuscle is just another free nerve ending to help you detect pain, heat, things like that in your skin. I think we got through everything there. So here's a great just structure list itself and the description if I said, if I didn't get to everything. So the Erector Pili muscle is smooth muscle. It's located at the base of the hair and it causes goosebumps when it contracts. You have blood vessels located throughout the dermis. They also serve the deep layers of the epidermis since the epidermis is avascular. So again, the epidermis is the outermost layer of skin and it's avascular. There's no blood vessels up here. So the blood vessels in your dermis layer will provide blood supply to that. Hair bulb and follicle, that's the structure that contains dividing cells that will help your hair follicles grow. The keratinocyte is found in your epidermis, and this will produce keratin, which is a protein that helps to protect your skin. Melanocytes are cells found in the epidermis. They will produce melanin to protect your skin from damage from UV rays. And melanin gives you the darker skin color, so that's why when you're out in the sun, your skin becomes dark, because your melanocytes are trying to protect your skin from UV rays. The nails protect the fingertips from trauma. Nerves and nerve organs. This is where we get our free nerve endings to help perceive pain. Pacinian corpuscles and Meissner's corpuscles, which are both mechanical receptors. Then you have sebaceous glands, which will secrete oil around the hair follicle. That will help protect the hair and keep the hair lubricated. And then sweat glands produce sweat to help cool down the skin. If you're really hot, you'll start sweating, and that'll help to dissipate heat.
Question.
Yep.
If you burn those, can they grow back? Kind of like your spine nerves, right?
That's a great, nerve?
Well, mine, so I do that for my spine. I burn my spine nerve so I don't have pain, in theory. And it lasts about a year and then the pain comes back.
So your nerve endings must have grown a little bit. I mean, nerve cells are constantly dividing as well. I don't know if they can regenerate completely. Which part, did you get burned on? Just a part of your skin?
No, so they go in there, I forgot what the surgery, they call it surgery, but it's not really surgery.
Cauterize them or?
Yeah, they just stick tubes
blood
in there and send like shock waves to it and then literally burns the nerve. It's pretty painful.
Okay. Yeah, I mean, I would assume if pain is coming back, then there must have been, maybe they didn't get them all as well. That could be.
Well, the doctor told me that they literally grow back
Oh, they do. Okay,
um,
yeah,
for the spine area.
that's
That's why I
really,
was curious about the hair.
if like the hair grows back then.
Yeah, the nerves for the hair part.
Um, yeah, I'm assuming they're regenerative so they can grow back a little bit. The hairs themselves don't really have nerves, but um, the nerves themselves will regenerate in a little bit. Yeah, to answer your question. Thanks for sharing that too. You had the military background, right? Yes, Mani?
Yes, ma'am.
Okay, I remember that. Okay. Thanks for sharing. So this is the same kind of picture, but a little more detail about the layers in the epidermis. And there's 5 layers in the epidermis. The stratum corneum is the outermost layer, the lucidum, granulosum, spinosum, and basale. These are just 5 different layers of the epidermis. The basale is where your dividing skin cells will start. And as the cells work their way up to the corneum, they'll become dead. That keratinized stratified squamous layer is that stratum corneum layer that you're seeing. They're filled with keratin, they're dead, they'll be sloughed off completely. You guys, if you're living with other people or even yourself, you're breathing in your own dead skin cells. So I think that's what this picture is showing, just the layers of the epidermis. Merkel discs, free nerve endings, these all have to do with nerves in your skin that will help detect touch and pain and temperature. And then again, highlighting the erector pili muscle and the sebaceous glands, which will secrete oil to help lubricate the hair.
It's funny that you mentioned the skin. Like if you guys replace your air filter and your main, air,
Yeah.
like 90% of that is skin.
Oh, gross. I know
Yeah, it's just pretty gross.
it's very gross. Yeah. I don't want to think about it, but yeah, I believe you, which means we should probably be replacing that often. Yes. So here it describes the layers of the epidermis. And again, the epidermis is the outermost layer of your skin. The corneum contains 25 to 30 layers of dead cells. They're dead keratinocytes, which help to contribute to your skin's waterproof property. So they provide this kind of protective waterproof layer. Then they will continue to be shed as the deeper layers of the cells below them push them outward. And this is good. Your keratinocytes, your skin cells are constantly dividing and regenerating themselves because they're being sloughed off so quickly. The stratum lucidum, is just a quirky fact about this that you should know. It's the only layer found in thick skin, like your palm and your sole. So in the palms of your hands and the soles of your feet, your skin is a little bit thicker. And that's partly due to the fact that you have an extra layer of dead cells in those parts of the body. And it just gives you a little extra protection in the palm of your skin and the sole of your feet. Then you have stratum granulosum, stratum spinosum, and stratum basale. You guys can read through these. In general, I would know the order of them, and about knowing the exact, like how many layers are in each, I wouldn't be worried about. You should know the stratum lucidum is only found in thick skin. The stratum basale is the deepest layer, think basement layer, and the corneum is at the surface. Your stratum basale layer will contain your skin stem cells, your melanocytes, which produce melanin, which will help to protect your skin against UV rays, and keratinocytes, which produce keratin. This is a look at skin of the human scalp underneath a microscope. So before this, we had pictures of just artistic renditions of the skin, but this is an actual picture of what the skin would look like. So again, you might see a picture like this in your lab exam. The biggest thing to spot right away is probably the piece of hair. And again, the hair shaft is the portion above the skin, and then the hair follicle surrounds. I was saying hair root. The hair root is the portion of the hair that's below the skin. The hair follicle surrounds that, and the hair bulb is the area where new hair cells will grow from. You'll see sebaceous glands next to the hair itself, and you'll also see these erector pili muscles attached to the base of the hair to cause the hair to stand up straight, like goosebumps. And then you'll see sweat glands a little bit deeper. If you look a little bit deeper, you can kind of see the papilla of the dermal papilla, that layer kind of reaching out into the epidermis layer above it. And actually this will explain that too. So here's your epidermis layer, and you can see the stratum cornea has all of these dead skin cells filled with keratin. So we often call this the keratin layer. And then you'll see other layers of the epidermis. Again, there's 5 layers of the epidermis. They're not delineated here, but this is showing thick skin. So that stratum lucidum layer would be there, which just gives it another extra couple layers of skin cells. And then here separates out the dermis, the papillary layer, and the reticular layer. And again, the papillary layer of the dermis just has these little bumps in it, and they're called papilla. And these little bumps or humps just have blood vessels going through them to help give blood supply to your epidermis, because your epidermis it's avascular because it has no blood cells or blood vessels in there. So the papillary layer are those papilla, and the reticular layer is everything below it in the dermis. Good question, Ryan. Yeah, so let's go back to the sweat gland. Oh, other way. So here are the sweat gland, and it should have a sweat duct associated with it, which will take it to the surface. But in this slice of tissue, it doesn't show, I don't see the sweat duct coming out. But if you look at the artist's rendition, I think they show the sweat gland and the sweat duct coming up to the surface. So all sweat gland will have a sweat duct, but depending on how the tissue was cut, it might not show that duct. But there's the sweat gland itself. When I say the tissue is cut, I mean the sweat gland is probably going that way first, kind of into the screen, and then up to the surface of the skin, and that's why we can't see it. Okay. So here is thick skin. Pigmented human scalp. So this will be thinner skin, so you'll see less layers. So even the stratum corneum will have less layers of the keratin. You'll see the melanin down here are these darker pigments. And again, melanin is produced by the melanocyte cells to help to protect your skin from UV rays. So this is a look at the scalp, thinner skin. Yeah, Richard, good question. So sebaceous glands, let me go back here. So yeah, so this is a look from a microscope at skin. So sebaceous glands, the easiest thing to remember to determine what a sebaceous gland is versus a sweat gland, a sebaceous gland will always be associated with a piece of hair. So if we were to label this picture, or this was on your test, and it's even pointing, if it's pointing at this gland, you'll know it's a sebaceous gland because it's associated with a hair follicle or a piece of hair. Sweat glands will be deeper and not around hair at all. This one's a little tricky because you can't actually see the hair, but I would assume the hair is right here and it would come out of this opening. So yeah, this picture will look different than this picture because this picture is like someone created this drawing. It's actually an actual model in the lab, but in this picture you can see the sweat gland is kind of more tubular in shape because it'll have a tube or a duct coming out of it. And the sebaceous gland, it almost looks more like cauliflower. It has like more lobes to its gland. It doesn't look much like a tube. It's kind of like a lobular type structure that surrounds the hair. So sebaceous glands around the hair, and sweat glands are more coiled tube structures that will lead up to the surface of the skin.
Yeah, the sweat gland was not part of the original lab picture.
Oh, it's not. Okay.
No, they just added it. Whatever he did, he just updated it.
Really? Okay. Well, then maybe okay, interesting. Yeah, if it's disconnected from the hair, then I would call it a sweat gland. I'm assuming, anytime we make lab exams, myself included, we try to pick out things that are easy to identify. So we would pick out a sebaceous gland right next to a hair follicle, and a sweat gland wouldn't be connected. It would be disconnected from the hair. Those are great questions. Thanks, Richard. Yeah, so literally your lab exam will be labeling black and white pictures like this. This is a great view. Actually, this is a beautiful picture. So this is under a microscope. The erector pili muscle will connect to the base of the hair. And you can kind of see, if you look closely, the erector pili muscle is more like just smooth, and glands will be more globularly shaped. You'll see more things going in on them. But sebaceous glands are connected kind of above that erector pili muscle.
So when you pluck a hair on the very bottom, sometimes there's like a white or like a clear like little ball. Is that the hair bulb?
I would assume so. Yeah, that's a good question. I would assume it would be, because if you're taking it out completely from the root, you're getting the hair bulb out of there.
Yes, that's how they do the hair implants. And then they also get the follicle to it with it.
How do you know about hair implants?
I had a soldier that had a hair implant, and I helped him to like take care of it.
Oh, wow. Okay, that's so interesting. Okay, thank you for explaining that. You're just a wealth of information.
That's why I'm mad. I'm mad at the military, because we get so much knowledge about just a whole bunch of fields, right? And then we come out of the military, 10 years later, and we have 0 degrees, and our heads are full of knowledge, and it's like it's pretty angry.
Yeah, you guys are so knowledgeable, and I can verify that, because every medical person I've had in class I've always learned something from them. Well, I learned from every student, because you guys all have different experiences that I have not had. But yes, especially military people, you guys definitely. I'm just going to copy and paste. We have one more slide to get through, but I'm going to copy and paste the activity in the chat. It's just about a 3-4 minute video, and then 5 questions. Again, easy points, so just take your time. And let me copy and paste this into the chat. And I'll finish up our last slide here. Oh, and that is this. Oh, sorry. Okay, so the last slide I think was just another picture of the same thing, but another there we go. Go back there. Okay, so we went through this slide. So this is just another cut of the skin, a sweat gland in the human scalp. So if you can see here, it's easy to see the hair follicle, which again surrounds the hair itself. Here's the sebaceous gland associated with that hair. And actually, Richard, I think this was your question. This is another almost better view of the difference between a sebaceous and a sweat gland. Not only is the sebaceous gland closer to the hair, but the sweat gland, you can see how it's more tubular in structure, and it's kind of windy tubes. So that's another way that you can kind of tell the difference.